Yes, class. Good evening. Am I audible? All are present. Astha, Emin, Imad, Liana. Who is this? Razan and Ryan. Fine. So, are you prepared for the test? You have a test. I hope you remember whole last lesson that you have. But before we begin the test, see, test is of 1 hour duration. So, before we actually begin with the test, just for 10 to 15 minutes, let's just quickly do one small topic, and tomorrow we'll complete all this lesson. So, in the next week, we'll start with electromagnetic induction. Again, I'm telling you all these lessons from now onwards. These are very small lessons. You don't have to go into much details in these. Only a little tough you can say that will come is your alternating current AC, in which is also not a very tough lesson. It's in comparison, you can say that. Otherwise, all these lessons are small lessons. So you will be having tests soon because most probably every week we'll be able to complete these lessons. EM waves is the shortest among these. Directly now you have ray optics, which is a bigger and a larger topic. Otherwise, rest of the topics which are present, these are very small. So we had started with bar magnet terminologies, we had seen properties, we had seen comparison what is left. Let's just do this comparison table, then I'll leave you. You people can appear for your test. Later on, we can discuss the questions. Now, electrostatics is there and magnetostatics is there. Certain things are present in under the topics and headings of electrostatics. Certain things are present under the headings of magnetostatics. Now, see class, what happens is that you have certain topics which are under electrostatics, and certain topics are there which are present in magnetics. So there's a relation between these. You can easily directly identify it by just looking at it. So here also, the way you can relate it in this manner. Linear motions you have done, then you have rotational motions. So linear motions are what? Linear motions, for example, force. Force is a translatory motion. And rotational analog of force becomes torque. So what had happened here? Force, the physical quantity remained the same, but here the analog became different. Similarly, in electrostatics also, you have certain properties whose analogs are present in magnetostatics. Magnetics or magnetostatics, you can say. So starting with the first quantity, that is your electric charge. We'll be discussing this. We are doing this in this manner because some of the topics we have not discussed together. For example, these electric charge and electric dipole, these topics were not discussed together. Now, electric charge is what? Electric charge is the basic or intrinsic property of matter that gives rise to various phenomena, which you can say like electric force, electric field, electric potential. All the phenomena are based on electric charge only. So, electric charge is the basic unit whose representation is by capital Q. The SI unit of electric charge is coulomb. 1 coulomb we use for depicting the electric charge. Now charges are also of two type, positive and negative. Then you have in magnetics, you have magnetic charge as well. But a magnetic charge does not mean a quantity like the electric charge. That is different. Electric charge actually exists. Magnetic charge basically means the magnetic strength. Plus Q and minus Q. And then you have magnetic strength. So plus M and minus M we use. Fine. Now electric dipole is the second quantity. Electric charge is the basic quantity that you have. And do you people know the CGS unit of electric charge? CGS unit of electric charge. Anyone? CGS unit of electric. SI unit you all know, no? That is coulomb. CGS unit. What Asa?
Stat coulomb.
Stat coulomb, exactly. It's stat coulomb or electrostat unit. Either you use ESU for it or you use coulomb for it. Now the next quantity that you have is electric dipole. Electric dipole is what? It's a set of positive and negative charge. These are separated by a small certain unit in it. Now, electric dipole, if there is one condition for electric dipole to exist, both the charges should have the same magnitude but with opposite signs. Plus 2 coulomb, so minus 2 coulomb. Plus 3 coulomb, so minus 3 coulomb. Minus 3 coulomb and minus 3 coulomb cannot make your dipole. Plus 2 coulomb and plus 2 coulomb cannot make your dipole. So plus Q and minus Q. If it's minus 3 microcoulomb, so plus 3 microcoulomb. That makes your electric dipole. So formula for electric, if both these charges are separated by a distance of 2a, then we say magnitude of charge multiplied by the separation between them. This is the formula of electric dipole. Most of you must have studied it. Then you have SI unit of this. SI unit is coulomb meter. Similarly, you have magnetic dipole as well. Magnetic dipole means magnetic charges separated by a distance, let's say L. So magnetic dipole moment is also M into S. Fine. SI unit, you can leave it for this. If you wish, you can put it for length, it is meter, for magnetism, it is magnetic field, it is decimeter. Fine. Magnetic dipole, because we will see a different formula, ampere per using ampere meter squared. I think we have discussed magnetic dipole in this batch. I think we have discussed it in the last lesson. Then electric field, you have electric field for a dipole plus Q minus Q for a point P which is lying on the axis of it. So formula of electric field is what? I'm writing K. What is K here? Constant in case of electric field, that is 1 over 4 pi epsilon. So here this is 2kp divided by rq, or even you can write 2p by 4 pi epsilon naught r cube. This is the formula of electric field for axial line. For axial line in case of magnetic, same thing. See, now you just have to replace certain things. Instead of K, which is 1 over 4 pi epsilon naught, for magnetic field, you write it as mu naught by 4 pi. Fine. So 1 over 4 pi epsilon naught is written as mu naught by 4 pi. Then 2 remains the same. Instead of electric dipole, you have the magnetic dipole divided by R. Fine. So remember, for electrostatics, convert it for magnetostatics. Remember it for one, you can convert it for another. Then you have equatorial point. For equatorial point, C class. The formula for magnetic equatorial point basically means plus Q and minus Q exist in nature. A point P is chosen whose radius vector makes an angle of 90 degrees. Fine, this is L or R, you can say. Let's write it as R. So formula of electric field is what? See, minus Kp by Rq is the formula. Minus K, I'm writing it as 1 over 4 pi epsilon naught Kp by Rq. Now for magnetostatics, just convert this. Plus M minus M at perpendicular point P. 1 over 4 pi epsilon naught is written as mu naught by 4 pi. Minus sign. Dipole moment becomes what? Magnetic dipole moment. M. R cube will be fine. So just remember one, you can convert it for the other. Torque is P cross E, which is written as P sine theta. For in case of electric field and presence of electric dipole. For magnetics, you have M cross B. So torque is what? MB sine theta. Or even you can write it as NAIB sine theta. Fine? That is torque. Already discussed, we just revising. Now work done is there because just see, this is the last topic for today. Work done means if I have a dipole plus Q minus Q and I have rotated it to some other angle. This angle I have rotated. So this was one angle theta 1, this was another angle theta 2. So work done's formula is minus E electric field is E and dipole I have not shown over here. Let's say P is the dipole. So P dot E, it is cos theta. But if you have two angles with you, work done's formula becomes minus PE cos theta 2 minus cos theta 1. Fine. For potential energy, this is PE, P dot E, same P dot E. For one, you can write minus, other you can write positive. Same thing occurs here as well. You have a set of dipoles. Now, which is now rotated to some other angle. This must be theta 1. Now it is shifted to some other angle, theta 2. So work done here will be what? See, minus M dot B. M dot B. And here work done will, you can write this as minus MB cos theta 2 minus cos theta 1, or potential energy will be minus M dot. So what you have to do, did you understand? You just have to remember for electrostatics. Whatever you studied, you have to remember it for electrostatics. For magnetics, just make the analog conversion. For example, we use the constant 1 over 4 pi epsilon naught in case of electrostatics. Use mu naught by 4 pi for magnetostatics. You use electric dipole for electrostatics. Use magnetic dipole for magnetostatics. Electric field, magnetic field. Fine. Whatever things are present, just make an analog of it. And when you have the analog, just remember whatever you studied for electrostatics and convert the final formula. Any doubts till now?
No, ma'am.
Yeah? Others as well?
Yes, ma'am, clear.
Yes, Asta.
Ma'am, for this point in the equatorial line, axial line, the derivations are also important, right?
Yes, derivations are there. Derivations are important for it. Not from magnetics, from electrostatics. Electric fields, axial derivation, and the playlist which I've sent you on the group now has the derivation, because this chapter was missed by you all since the batch has started late. So this part we had not done it together. That's why you must not be able to recall it. But I have sent you the playlist. The derivations are there, and derivations are important for the electric field and axial field. The derivations are important along with the approximation. This formula comes after ideal dipole approximation. The formula is actually a little different when you do not have the length of the dipole as so short. So yes, a derivation for this topic, this is there and it is important. So do refer it from the playlist if you have any doubts, or you take the derivations from me simply for the first 2 or 3 lessons at least. You all can at least take the derivation. Yes, derivation is there. Even this Torch derivation is also there. P cross E, you cannot remember the formula directly, P sin theta. This is just that we are revising the formulas of electric fields before we write down the formula for magnetic field. But more than magnetic field, these derivations are important for electric field. Derivations from this lesson do not come, usually do not come. It can come in your paper, there's a very slight possibility, but most probably questions come from electrostatics only if they are derivation based. From this chapter 5th, derivations do not come. You have the numericals from this only, torque and magnetic strength and all. Then you have the theory questions from the differences between diamagnetic, paramagnetic, and ferromagnetic. Mainly. Got it, class? Yes or no?
Yes, ma'am.
Note it down and just text me done when you have written.
Ma'am,
Ma'am, I have a doubt.
Yes, Anushka.
Ma'am, I actually joined a bit late, so can you please explain this comparison between these magnets?
Comparison. Okay, see, electric charge, electric charge you have already studied, and electric charge is what? Electric charge is just the basic or intrinsic property of matter. Now, what happens? We are just comparing electrostatics and magnetostatics together. So under electrostatics, you have electric charge whose analog is magnetic charge. Magnetic charge is not actually a proper term to define it. You can remember it in terms of magnetic intensity. Fine. If you have magnetic charge with you, you can just remember it in terms of magnetic intensity. Intensity, I hope you understand. Intensity is how much the amount or the magnetism properties it can show. Like electric charge. Electric charge was the property and it gave rise to different phenomena. Those phenomena included your potential, you had your forces with you, different phenomena existed. In case of magnetic charge, you have the strength of it. You can say basically the intensity, or you can say now you have electric charge. We'll do what? We are just making a list of things that are possible from electric charge and we are comparing it with magnetic. Whatever things are possible. Now, SI unit is also here magnetic, but Tesla only used for this. So that's why I've not written it. You can add it also. We write it Tesla only. Electric magnetic field it is depicting, no strength it is depicting. Then you had a quantity dipole. So dipole is a set of positive and negative charge. So when these positive and negative charges are there with the same magnitude but the opposite direction, opposite signs you can say. If one is positive, other has to be negative. For example, you can have plus 2 coulomb, minus 2 coulomb as a dipole, minus 5 millicoulomb and plus 5 millicoulomb as a dipole. You cannot have plus 5 millicoulomb plus 5 millicoulomb as a dipole. Though they are having the same magnitude, their signs are not opposite. Signs have to be opposite when you're dealing with dipoles. Similarly, okay, the formula of electric dipole is separation between the charges and the length between them. See, magnitude of one of the charges. So Q multiplied by 2A. Magnetic dipole was strength of magnetic field, that is your magnetic charge which you say, multiplied by the length they possessed between each other. Now, electric field's formula you must have done in case of axial line and equatorial line. Now, how to make a comparison of this is important because you will be remembering maximum formulas of electric field only because that's a chapter that is done initially. Tests have also been done. So, you tend to remember this lesson, but remembering magnetic formula becomes difficult. So, what to do? Remember, constant in case of electric field is 1 over 4 pi epsilon naught. Here that constant becomes mu naught by 4 pi. So 1 over 4 pi epsilon, wherever you see this constant k, convert it into mu naught by 4 pi, the constant k's value. Wherever you have electric field, convert it into magnetic field. Wherever you have electric charge, that is magnetic charge. Electric dipole moment got converted into magnetic dipole. That is what we have done. So 2 kp by r cube is the formula of electric field. That became 2 km by r cube, but the values of k became different. Similarly, in case of electric field for equatorial point, formula is minus kp by r cube. Here also it became minus kp by r cube, but the value of k was different, km by r cube. And instead of p, you have m, that is magnetic dipole. Then torque is P cross E, which is PE sine theta. Yes, Asta, I am scrolling up back. You can, I'm even scrolling to the first part. Let me just repeat once, then you can note it down. Torque is what? Torque is P cross E. So PE sine theta, there's a derivation, small derivation is also there. Now, even without doing the conversion, even without doing the formulation, just what you can do, even without doing the derivation, you can do one thing. Dipole moment, make the dipole moment of magnetic, that is M. Electric field, make it magnetic field. Rest of the story remains the same. So it becomes M cross B or MB sine theta. Work done, I think you have joined, no? And when we are doing work done, Anushka?
Yes, ma'am.
Oh. So I hope it's clear. If any doubts you have, you can still ask me. I'll explain any. So note it down. In whichever point you're not able to understand, just name the point number. I'll explain you.
Yes, ma'am.
Done? Just text me done once you've written. So Astha, Razan, and Iman. Okay, others also right. Anushka done. Eman, Liana, Rayan, just let me know once you've done. See, marks are written in front of it. So according to the marks, just solve the questions.
That is 9.375 into 10 raised to minus 4 minus 1.563 into 10 raised to minus 4, which is 7.812 into 10 raised to minus 4 Newton. And it was directed away from the
Yes, Asta?
no, nothing.
Asta, are you asking something?
No, ma'am. By mistake, I on the mic.
Okay, okay.
Ma'am,
Yes, Anushka.
ma'am, can you copy the fourth question in the chat box because the screen went blur for me.
Screen is blur for you all.
Ma'am, I don't know about others, but for me it went blur. That's why.
Okay, before that, others tell me, are you able to see the screen, all the questions?
Yes, ma'am.
Okay, okay. Then I think Anushka, it must be your internet. Okay,
Yes,
I'll
ma'am.
copy it.
Yes, ma'am. Thank you, ma'am.
Okay, Asta, I've received your paper. You can leave.
Thank you, ma'am.
This class now wrap up your answers, make into a PDF and send it on the group.
Yes, ma'am. Ma'am, I'm done. I'm just sending it now.
Okay.
Ma'am, I've sent.
Okay, Anushka, you can leave. Others also submit your sheets.
Thank you, ma'am. Bye, ma'am.
Almost done, ma'am. Last one.
Razan can also leave. Razan.
Okay, ma'am. Thank you.
Thanks, ma'am. Here it is.
Yes, Imad's have also got. Emin, Liana, Rayan, hurry up.
Thank you, ma'am.
Ma'am, I'm not actually in the group.
Okay, Ryan, you're not on the group. I'll send you my number. Just send me there. I'll get you added. Yeah, Liana can also leave. Diana and Imad. Razan, I've sent you my number. Just check once.